Hello everybody and welcome back to question number 8 on the 2006 Euclid paper. Okay, so we're getting into the written only sections of the contest. We have to justify everything. No more light bulbs. That was question 7. We're looking here at question 8. We've come a long way. And I think it's been a good paper so far. I like this one. And we just have 8, 9, and 10 to go. And these are typically the hardest questions. So if you don't get them, hey, that's okay. You've made it this far, and that's great. Even if this is your grade 12 year. 8, 9, and 10, really challenging. All right, so let's take a look here. So 8, we've broken it up into 2 parts. If log base 2 of x minus 2 log base 2 of y is equal to 2, determine y as a function of x, and sketch a graph of this function on the axes in the answer booklet provided. Okay, so 2 things. One, I don't have an answer booklet, although my notes do have sort of graph paper, so I will sketch a graph. It's always weird when they say sketch a graph on the older contest. How much information do I put in? Graph sketching is not the biggest part of the curriculum anymore. It's basically all pre-calc. But we'll do our best with that. And the second thing I want to note is logarithms. Scary logarithms. Not at all. As long as we understand the definition of logarithms, which I'll remind you guys. These 2 statements are equivalent. A to the B is equal to C. This is expressing the exact same thing as log base A of C equals B. Exact same expression. Logarithms are just canceling out exponents. Okay, so there's 2 ways to cancel out exponents. If I have x cubed is equal to 8, I can cancel out the 3 by cubed rooting. But if I have something like 3x equals 9, I want to know what x is. I can't just x root everything. I don't know what x is. Logarithms are how you cancel when you know what the base is. Okay? And this is what I have to explain to my calculus students all the time. And now logarithms have a bunch of nice properties. I'm not going to detail them here, but I think we'll be using a few of them. The logarithm properties usually pop up. The most basic properties are really all we need for these questions, and I think it was equal to 2. Let's just double check. Log 2x minus 2 log 2y equals 2. All right. So we want to solve for y as a function of x. Okay. What can we do? Well, we got to try and get y all alone, y just by itself. Now he's trapped inside a logarithm, and this makes me start thinking about things. If I have a constant out in front of the logarithm, I can change it. And we will be writing all our steps here because it's a written question. I can bring it inside as an exponent. Okay. And then I have a difference of 2 logarithms with the same base. I can change that. So it's x over y squared equals 2. And now I've got a statement like the one up here, so I can transform it into 2 to the 2 is equal to x over y squared. Okay, so that's really just 4 is equal to x over y squared. And I will rearrange that to y squared is x over 4. And we will say y is the square root of x over 4. Or you could say square root of x all over square root of 4 is 2. That would be fine. Lots of options here. Notice that it's not plus or minus because we have to put y in here, so y will never be minus. You'll never put in minus 2 for y. Log to any base of a negative number is absolute gibberish. It just doesn't make sense, at least not for high school level math. You get lots of things can be put in logarithms if you take a complex analysis course, but that is really beyond what we're going to talk about here. So our function, the function is y equals, we'll stick with root x over 2. So if I want to graph this, and I will on the next page because I didn't leave myself enough room because I wasn't thinking ahead. Okay. So y equals root x is something you should probably know what that looks like automatically. So we'll put that in purple. This is not the function that we're going to need. But it sort of looks like this, and it's at 0, 0. It's at 1. It's at 1. At 4 over here, it'll finally be up to 2. That sort of thing. And so, knowing some of these nice points, you can very quickly plot this out. But it sort of looks like a half a parabola that's just sort of fallen over on its side. Okay. One other thing I'm thinking about. Because you can't put negative numbers in for a log, you also technically can't put positive numbers, or you technically can't put 0 in either. So I'll say for x greater than 0, since log of a negative number and log of 0 are meaningless. And not only have I ensured that the log base 2 of x makes sense, but also the log base 2 of y will make sense. Okay, so if we're being super, super accurate, we wouldn't actually hit this point down here. We should be drawing an open circle. We can get as close as we want, but we'll never actually get to 0, 0. Anyways, this is y equals x squared. Well, we don't want to draw y equals x squared. We want to draw y equals a half. And I said y equals x squared. Y equals square root of x is what I'm talking about. We want y equals square root of x over 2. Well, if I have y equals root x here, then to plot a half of that, we just move everything down by a half. Okay? So we still won't get anything there, and it just we sort of have shrunk, sort of squished it down by a half. And so at 1, it'll pass through 1 and a half. It'll pass through 4 and 1. It'll pass through 9 and 1.5, that sort of stuff. And you can plot a couple of those points to show them, yeah, I really know what I'm talking about. But that's really all we need. Okay, so that covers everything we need for A, right? Determine y as a function of x. Got it. Sketch a graph of this function on the axes. Well, I don't have the answer booklet, but I did an okay sketch, and if I needed to beef it up more, I'd plot some points, things like that. All right. So 8b. In the diagram, AB and BC are chords of the circle with AB less than BC. Okay. If D is the point on the circle such that AD is perpendicular to BC, and E is the point on the circle such that DE is parallel to BC, carefully prove, explaining all steps, isn't that what we're supposed to be doing anyway? I guess we'll just be a little more accurate than I usually am, that angle EAC plus angle ABC equals 90 degrees. All right. So let's draw the picture. Since I'm going to need to refer to it, I'm just going to do a fresh sheet. Okay, we're not wasting paper. It's digital. We might need it a bit bigger, but we'll roll with it. What's a good color to use? Green. So A up to B, and then down to some point C. We are told that one is bigger than the other. I don't know exactly how that's going to help. Actually, we'll keep the whole thing together. So then we make a perpendicular, but these are all going to be perpendicular. So right now I'm seeing we've got A, B, C think they called this F, and this is a D, and then it's parallel, so we get E here. So I might say something like, notice that ABF is a right-angled triangle. So angle ABF, which is equal to angle ABC, which is equal to angle ABF, plus angle BAD is equal to 90 degrees. So I guess it suffices to show that the angle up here is equal, and they want, we don't even have it listed yet, they want EAC. So I want to show this angle is equal to this angle. Okay. I don't know that this is the right way to approach it, but it's just the first thing I see. I've got the right angle, so these two angles, and one of them is one of the ones I'm talking about, happens to work. So we're working through this. And it was EAC, right? I don't want to start this off the wrong way. Yeah, EAC. Okay. What can we do? And again, I want to reemphasize, I don't know if having, like, these guys have to be equal based on the statement. Is this the way to prove it? I don't know. Or is proving that these two, ABC and EAC, add up to 90 a way to show that those two are equal? I don't know. What can I do? Well, so these are angles. They're both at the same point, which is A. And I think that means, so I know angles subtended from the same chord are equal. This is a fairly famous and well-known result. Angles subtended from the same chord must be equal. But I believe angles that subtend the same length must be equal as well. Is that true? And if so, is that an easier thing to show? Right now, I don't have a plan of attack. I'm sort of just vomiting up anything I can think of from their diagram. So I could either, show that the two angles that they asked for add up to 90 degrees, or now I have another option. I can show that angle BAD is equal to EAC. That's an option. Will that work? I don't know. But now I think I've got another option. So I could either show the angles that they want add up to 90 degrees, or I can show those two angles are equal, or I think it suffices to show that BD is equal to CE. So that would give me another option. Whether or not that's true either, I don't know. But I'm going to explore that and give myself another option. Okay? So I might even say, because I don't know how well known this is, and I'm actually not entirely sure, claim angles subtending the same length are equal. Now it certainly works if that length happens to coincide, like it's both the same chord. Maybe we should rephrase this. Angles subtending chords of equal length are equal. So this is my statement. If it was something like angles subtending the same chord are equal, I would not bother making this a claim. But I don't know how well this fact is known, if indeed it is a fact. So first I'm going to state my conclusion. like, why am I introducing this claim? By the claim, it suffices to show CE equals BD. Whether or not this is easier, I don't know. But let's go ahead and prove this claim just so I'm not completely making things up in case this actually works out. So let's have P, Q, R, and S. So I'd say proof of claim. Suppose PQ is equal to RS. We'll call this O. OP equals OQ equals OR equals OS. So by side similarity, triangles OPQ are equal to triangle ORS. That tells me angle POQ is equal to angle ROS. Now for any other points, and we'll use another color, so for any point T here, and I don't know, any point U here, it's well known, and I prefer to call this the Star Trek theorem, and I've actually seen people cite it as such. But basically, if we've got a chord and we connect it up to the center and connect it to some other point, the angle at the center is twice the angle at the point. So we see that angle PTQ is 1/2 angle POQ, which is 1/2 angle ROS, which is equal to angle RUS. And that finishes that off. Okay, so now it really does suffice to show C equals BD. Was this a useful distraction? I genuinely don't know. Is this going to lead somewhere? No idea. But I have more options. I have more options now. So now I can just continue to look at this picture and say, what can I do? One thing to note, I've used most of the information. I haven't used the fact that AB is less than BC. Is that a requirement? Like, I haven't used that fact, and does that help in any way? So I can't tell whether or not this condition is if you don't have it, you don't actually get such a point E or something like that it's necessary for the setup, or whether or not this is sort of a condition that they're giving me that will help me in my proof. I'm inclined to think it's the former, just because they started off rather than giving us additional information saying, oh, by the way, AB is less than BC. But I'm not seeing how it would be required for this setup. If AB was greater than BC, then we could just swap the letters around. You could still get a perpendicular and D, and it would still be... You'd still be able to get an E, wouldn't you? Yeah, because if we just swapped the letters A, B, and... So, I'll draw what I'm talking about. I don't know why they said AB is less than BC. I'm thinking maybe it's part of the proof, because if AB was much bigger than BC, I could still extend A as long as A passed through the line A through the center will have to. Actually, no, that's not necessarily true. And in fact, yeah, because if it's much shorter, then we could have something like this, and then there is no way to get A through. Okay, so it's part of the setup. It's part of the setup. There's no way to get A to perpendicularly cut this. So I don't think I need to use the AB less than BC. So let's go back and look at my picture and see if there's anything jump out at us. So I've used the right angle to change the question in several ways. What other information did they give me? So the creation of D is what made that perpendicular line. The perpendicular lines. That's fine. The other stuff they gave me is DE is parallel to BC. So can I use that? So they're parallel chords. I'm going to draw a bigger version of this. So C, E, B, D, F here, and there's perpendiculars. And speaking of perpendiculars, if I put in point O, I mean, it's going to have to go through. I can draw a radius that's perpendicular to BC, and that radius will have to also be perpendicular to DE. And that means that they cut them in half. And I'll call that X, call this Y. So this part's X, this is Y minus X. X, X, Y minus X. And I think it's a rectangle, so these lengths are the same. Hey! Okay. So I'm going to talk out what I've got. So we're going to continue on. Let O be the center of the circle. We can draw a radius from O, which is perpendicular to BC, and since DE is parallel to BC, it is also perpendicular to DE. Okay. So that sets up these perpendicularities, which starts setting up a rectangle. What else do I want? Okay. Since we have a radial line or a radius, perpendicular to our chords, we conclude that the radius passes through the midpoints, and we'll call them G and H of BC, DE, respectively. Okay. Now, I want to talk about this line. Draw, and we'll call him I guess, from E got EI, so I is on BC, and EI is perpendicular to BC. Should I justify that? I'll say something like DE is less than BC, so such an I is inside the circle. I think that's fine. You might not even need that. Okay, so I've got FDEI, and I've got GH. Okay. So FDEI, FDHG, and EIGH are all rectangles. So I'm going to let GF equal DH equal HE equal GI equal X, and we'll let BG equal GC equal Y, and we'll also let trying to think in my head without bouncing back because I don't want to switch the page. FD equal EI equal Z. Then let's notice that IC is equal to Y minus X is equal to FB. Triangle BFD and triangle CIE are right angled. I'm going to redraw the picture just very briefly because me writing, not as much fun as me writing and you guys being able to follow on a picture. In case you have forgotten what the other one looked like, these are just terrible circles. Alright. That. Dropped the perpendicular. And then we created EI. So we have some right angles, and then we've got these purple lines here. And this purple triangle, I guess, these purple triangles are by side angle side. We see that they are congruent triangles. Did I say when I proved my claim that I used side angles, side? Yeah, okay, by side. I should technically have the congruency symbol, or at least the one that I remember. Two sort of squiggly lines, as opposed to one squiggly line for similar. So they're congruent triangles, therefore BD equals EC, and the result is shown. There's I, G, H, E, F, B, D, A, C. So those two lines were equal, so the angles, they subtend are equal, and we know that this one and this one have to add up to 90. So that finishes it all off. Okay. That was a lot of chasing, and I'm sure that was not the only way to do the question. A lot of diagram chasing. Probably not the only way to do the question. I'd be interested to read theirs. In fact, I'd be interested to read yours if you guys feel inclined to leave a comment detailing how you approached it. But yeah, not such a bad geometry question there. Challenging nonetheless, because you had to sort of, at least the way I did it, you had to make those connections that, oh, it's got to be this angle here and this angle, so the lengths have to be the same, and now how do we devise a way to get those lengths equal to each other? It was not at all obvious to have the radius bisect those two lengths, but it all worked out in the end. Okay, so yeah, question 9 will be the next one that we tackle. And then we're very close to being done. Question 9 and then question 10, and then it's all over for the year 2006. So thank you guys as always for watching, and I will see you for question number 9 in the next video.